thing we're going to do is synthetic division. Synthetic division. Synthetic kind of sounds like fake, right? And that's kind of what synthetic division is. I call it fake division. Synthetic division is kind of fake division. Because what it does is it does the same thing. This is kind of like an LOL, right? It's not really fake, but it's an easier way to do long division. And now you're like, what? An easier way? Why wouldn't you have shown that to us before? An easier way to do long division. Well, it really only works when you have simple divisors. So it only works for simple divisors. Only works for simple divisors. And what do I mean by a simple divisor? Well, if you look at all the things that are being divided by, here it's being divided by x minus 3, m plus 1, z minus 1, x minus 3. It's always just a plain variable, right? And then a number. So that's what we mean by simple divisors. And we're only going to ask you to do synthetic division with simple divisors. So there's a big step-by-step, which I have written on the notes that are posted online. I'm just going to walk you through it here. First thing we do is we put the opposite of the divisor number aside. So that was a negative 3, and so we put aside a positive 3. And then we line up the coefficients, which are 1, 3, and negative 18. And again, I'm just getting that from 1x squared, 3x, and negative 18. And I drop the first number down. So opposite of the divisor in the box, coefficients lined up, drop the first number down. The main thing that I do in synthetic division is called multiply, add, multiply, add, multiply, add. I multiply the number in the box times 1, which is 3, and then I add up 3 plus 3 is 6. Then I multiply 6 times 3, which is 18, and I add those two numbers up in 0. And I'm actually done. It doesn't seem like I'm done, but I'm done. The last number is always the remainder. The second to last number is always the coefficient, constant term, and then this is the coefficient of the x term. So your answer here is 1x plus 6 or x plus 6. And if we go back and kind of look at the problem in its entirety, what this problem said was x squared plus 3x minus 18 breaks down into x minus 3 and like kind of what, right? And so x minus 3 divides into that polynomial x plus 6 times. Now you might say, well, I could have just factored it. Yes, you could have, right? But that was kind of just an easy example. Many of the examples are going to have a remainder. We just started you out with a few that don't have a remainder. So if we look at this one here as another example, we put the opposite of the number in the box. We line up the coefficients 2, 5, and 3, make our line, and drop the first number down. That's the setup. Then we multiply, add, multiply, add, multiply, add. We're always multiplying this number by the number in the box, and then we're adding up our column. 5 minus 2 is 3. Then we multiply again that number by the number in the box, negative 3, and add them up to 0. Our last term is our remainder. This second to last term is the constant, and then this is the x coefficient, so here it's 2m plus 3. So again, that could have been factored. Now we finally get into one that has a remainder, so we're going to take the z minus 1, opposite of the number in the box, line up our coefficients, 1z cubed, negative 1z squared, 1z, and 8, drop the first number down. Multiply, add, multiply, add. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. 1 plus 0 is 1. 1 times 1 is 1, and 8 plus 1 is 9. And that's my answer, but this time I actually have a remainder of 9. And my answer is going to always decrease by 1 power from the original. So this is going to be basically 1z squared plus 0z plus 1 with a remainder of 9. But we're going to clean that up a little bit and write it as z squared plus 1. And then the remainder always is put over the divisor. The remainder is always put over the divisor. And onwards we go. So here in number 3, the opposite of the number here is 3. Now watch what's going to happen when I line up my coefficients. 1x to the 4th, 0x cubed, 0x squared, 0x, negative 81. Drop the first number down. Why did I have to add the zeros, right? The zeros are our placeholders. Not unlike if you were subtracting 4 minus 2.6, and I would say, you would probably be like, oh, 4.0 minus 2.6. And then I can do my borrowing, right? So you kind of add that placeholder in to hold that spot. Same thing here, and we're holding a spot of a 0x cubed, a 0x squared, and a 0x. Once I drop the first number down, now I multiply. 1 times 3 is 3, and add up 0 plus 3 is 3. Multiply 3 times 3 is 9, 0 plus 9 is 9. Multiply 9 times 3 is 27, 0 plus 27 is 27. And then finally 27 times 3 is 81, and negative 81 and positive 81 is 0. So I'm happy that we have 0 remainder. This is my constant term, my x squared term, my x cubed term. Remember, it always goes down by 1. So 1x cubed plus 3x squared plus 9x plus 27. And of course, I don't even have to say 1x cubed. If I want to just make that x cubed, that's fine too. Either way. The last thing are these K problems. You do have a K problem on the quiz. You would, or test, even both, you would set aside the opposite of the number. We basically do it the same way. Line up the coefficients, 1, 6, and K. Drop the first number down. Multiply, add. 1 times 3 is 3. 6 plus 3 is 9. 9 times 3 is 27. K plus 27 is K plus 27. At the end, I go back to my directions and notice, hey, it said that the remainder is 5. K plus 27 is the remainder, so if I subtract 27 from both sides, I get negative 22. So you do the problem the same way and then follow the directions for what to set the remainder equal to. Here, x plus 2, opposite of the number side. I got to be careful here when I line up my coefficients. 2x cubed, 5x squared, but what do I need to add? Right, 0x and then k. Drop the first number down. Multiply, add, adds up to 1. Multiply, add, adds up to negative 2. Multiply, add, and then that adds up to k plus 4. But it says in the directions, remainder is 5, so all I got to do is subtract 4 from both sides, and k is, 1. K is 1. So it'll take a little practice, but you will get good at synthetic division.